Welcome to this explainer. Today, we are diving straight into a phenomenal framework published on KD Nuggets by Vinod Chugani. What we're looking at is a highly specific, 5-step roadmap designed for 2026. It's built to take you from a general machine learning practitioner to a fully production-ready LLM engineer. This is literally the blueprint for a major career transformation, and we're going to review it layer by layer.
Right out of the gate, we've got to reframe how we even think about this role, because it represents a massive shift in the tech industry. You know, a general ML engineer often spends months training a neural network from absolute scratch. But an LLM engineer's real superpower is entirely different. It's taking highly capable, pre-trained foundation models and adapting, orchestrating, and serving them to build reliable, real-world products. You're no longer building the engine from the ground up, you're building the race car around it.
So here is the exact roadmap we're taking today. First, building the foundation. Then, prompting and tool calling, building retrieval systems, fine-tuning and alignment, serving and operations, and finally, building your portfolio. Now, this 5-layer stack, it is definitely not random. It's a carefully sequenced journey where every single layer relies heavily on the foundation beneath it. We're starting from basic token intuition and building all the way up to handling live production traffic. If you try to skip ahead, the whole stack just collapses.
All right, let's kick things off with Layer 1, building the foundation. This is where your real engineering journey begins. Now, you don't need to rederive all the complex math from first principles, we're kind of past that, but you absolutely must have a rock-solid intuition for how these models actually breathe. You need a working understanding of 4 core concepts: tokens, which are the basic units models process; embeddings, which is how those tokens become vectors; attention, which dictates how models weigh relationships; and the transformer block itself. And you've got to be completely comfortable doing this in the default working environments of 2026, PyTorch and the Hugging Face ecosystem.
To really anchor this layer, you need to prove it to yourself. So your first project is beautifully simple. Actually load a small open model using the Transformers library and run text generation from a basic prompt. Getting a concrete hands-on feel for that tokenize, forward, and decode loop is absolutely critical before you layer anything else on top of it.
Moving right along to Layer 2, prompting and tool calling. Listen, prompting is absolutely not just a soft skill anymore. It is literally your primary engineering lever. Systematic prompting means you're using structured system messages, deliberate few-shot examples, and crucially, JSON output schemas so your downstream systems can actually parse the results. Plus, you have to master native tool calling. This is what allows the model to act on external states, meaning it can interact with the outside world, and it forms the architectural seed of true agentic systems. You'll also want to look into frameworks like DSPy, which treats prompt construction as a programmatic optimization problem rather than just trial and error.
So for Project 2, you're going to build a dispatch loop. You'll create a command line tool where the model recognizes it needs a specific tool. Your code reaches out to a live external weather or stock API, and then feeds that result right back into the model to generate the final answer. You are officially connecting the AI to reality.
Next up is Layer 3, building retrieval systems. This right here is how we bridge the massive gap between public foundation models and your private proprietary data. Enter RAG, or Retrieval Augmented Generation. It's the industry-standard architecture for solving the hallucination problem. By retrieving real, factual documents and injecting them directly into the model's context window, you are literally forcing the model to read the facts before it answers.
The baseline RAG pipeline is just incredibly elegant, and it relies perfectly on the embeddings you learned back in Step 1. First, you chunk your text documents. Second, you embed those chunks into mathematical vectors. Third, you store them in a vector database. And fourth, this is the payoff, you retrieve the most mathematically relevant pieces exactly when the user asks a question. But let's be real. Your actual engineering work starts when that naive baseline retrieval inevitably fails. And trust me, it will fail. Sparse keyword search and dense embedding search often miss completely different things. To fix these missed signals, you have to combine them using hybrid search, implement rerankers to logically reorder the results, and use orchestration frameworks like LangChain, LlamaIndex, or LangGraph to manage the whole process. To prove you've truly nailed Layer 3, your project here is building an agentic, self-reflecting system. If your initial document retrieval returns low-confidence results, your system needs to be smart enough to catch its own failure, automatically rewrite the user's query, and search again before generating a final answer to the user.
All right, layer 4, fine-tuning and alignment.
This is where we go from merely orchestrating the model to fundamentally altering its DNA. When prompting and retrieval just aren't enough, say you need a highly specific domain vocabulary or a strict corporate tone, you turn to fine-tuning. But instead of massive, expensive full-model training runs, you're going to use parameter-efficient methods like LoRA. LoRA lets you train a tiny set of adapter weights on top of a frozen-based model, which gives you incredible behavioral changes for a tiny fraction of the compute cost.
And to perfectly align that model with human preferences, you're going to utilize DPO, or Direct Preference Optimization. It works by feeding the model pairs of preferred and rejected answers. It's an incredibly elegant method that has largely replaced the older, much clunkier RLHF pipelines we used to see everywhere in the industry.
Your fourth project is where you roll up your sleeves and do the hard work of dataset curation. You'll curate clean preference pairs to fine-tune a model so it perfectly matches a specific corporate tone using LoRA. And you'll prove your success, not by just eyeballing the text, but by using programmatic evaluation tools like Ragus to rigorously score the outputs.
Finally, we reach the top of the stack, Layer 5, Serving and Operations. Because look, getting a model working smoothly on your local laptop, that is a totally different beast than surviving wild, real-world production traffic. To handle that, you need a dedicated LLMOps toolkit. To serve multiple requests at once and maximize your GPU usage, you'll rely on high-throughput tools like vLLM. You'll use LLMOps for rapid local testing, bits and bytes for quantitation to slash your memory footprint, and critical observability platforms like Phoenix or Weights and Biases to track experiments, log inputs, and monitor your latency.
To conquer this final operational layer, you're going to take that RAG system you built back in Layer 3, wrap it tightly behind a lightweight API, and heavily instrument it with a telemetry logger. You need to be actively tracking your token count, monitoring user latency, and calculating your estimated cost per call. You definitely do not want any billing surprises when you actually launch.
And that brings us to our final stop, building your portfolio. So you've built this massive 5-layer stack. How do you actually prove it to the world? The source material is brutally honest here. Skip the certificates. A public portfolio featuring a working, interactive demo of a retrieval system or thoroughly documented evaluation results from a fine-tuning run will get you hired infinitely faster. It demonstrates raw, undeniable competence. And if you already have a machine learning background, this entire roadmap realistically takes just 3 to 6 months of highly focused work. The leap from a general ML practitioner to a specialized LLM engineer is easily one of the biggest career opportunities of the decade. We've laid out the entire stack, step by step, project by project, exactly as the source material outlined. So it all boils down to this. The blueprint is completely laid out in front of you. Are you ready to open your code editor and start Layer 1 today?